students, welcome to the class. So today we'll take few more examples, that means problems under nuclear chemistry. Okay, that means to find out the decay constant or half-life period. Okay, now the second problem yesterday we have solved, that means in the previous class, and once again we'll recall the same. Say the second problem is, say here, half-life period of iodine 125 is 60 days. Half-life period of iodine 125 is 60 days. What is the percentage of original? What is the percentage of original would be present after 180 days? Okay, so what they have given after 180 days means it is T. Okay, so what is the percentage of original left? That is, original must be 100 and N we have to find out, and they have given T half, that is 60 days. Okay, so here T half they have given 60 days, N we have to find out, N0 100, T 180 days it is given. Okay, we know this relation, N is equal to N0 half raised to T by T half by putting all the values. So substituting the values on simplification you will get 12.5%. Okay, it is the answer. Say after 180 days, say 12.5% of the original will be left. Okay, so now the third problem. See, the radioactive substance decays at such a rate that after 68 minutes only 0.25 of its original amount is left. Calculate the lambda and T half. So what they have given? See, the radioactive substance decays at such a rate that after 68 minutes, after 68 means it is 68 is T. T is equal to 68 and only 0.25 of its original. That means N is equal to 0.25. So of its original means N0 must be 1, and calculate lambda and T half. So okay, in this problem they have given T 68 minutes, N0 is 0.25, sorry, N is 0.25 and N0 must be here 1.0, and we have to find out lambda, decay constant and half-life period. Okay, so we know that this relation it is known to us, isn't it? 2.303 by T log say N0 by N. So all values are known to us here. T they have given 68 and N0 is 1, it is 25.25. So on simplifying you will get 0.0204 per minute. It is the lambda. So okay, now T half. T half is 0.693 by lambda. So this value put in here. So on simplification you will get 34 minutes. It is the half-life period. Okay. So now we'll move on to the next example. Say the fourth problem. See the 2 micrograms. The fourth problem is 2 micrograms of phosphorus was injected into a living system for a biological tracer studies. The half-life period of P32 is 14.3 days. How long will it take the radioactivity to fall to 20% of its initial value? So 2 micrograms is injected. That means here it is N0 is 2 microgram. Okay, and the half-life period T half is 14.3. Okay, so how long it takes? That means we have to find out the T to reduce the initial amount to 20% of it. That means 20% of 2 microgram. So when it remains undecayed state, isn't it? Okay, in this problem they have given N0, it is 2 microgram, T half 14.3, N equal to 20% of N0. That means 20 by 100 into N0. And we have to find out after what time. Okay, this much will be left. So that T we have to find out. So here N is equal to, we'll simplify this one, get the value for N, we'll simplify this one, 20 by 100 into 2, 0.4 micrograms is N. N0 is 2. We know this relation, T is equal to 2.303 by lambda log N0 by N. But they have not given lambda, so we have to calculate lambda. Here lambda is equal to T half they have given, 0.693 by T half gives to lambda. Okay, by putting this value here and on simplification you will get the answer, that is 33.33 days. So after this much time, so okay, the 20 to 20% of the 2, that means it will reduce to zero point 0.4 micrograms. So this is N0 will be reduced to this amount after these many days. Okay, are you clear? Okay, so with this we'll move on to the next one, that is nuclear reactions or nuclear transmutation reactions. Okay, so here there are different nuclear reactions are there, and out of them they have mentioned only 6 for you. Okay, say here the examples are, say alpha neutron, alpha proton, proton alpha, proton neutron, neutron alpha, neutron proton. So these are the nuclear reactions or the types of nuclear reactions or nuclear transmutation reactions. See, the nuclear reaction is the one where the nucleus is going to react. That means where the nucleons are participating in the reaction. If there is a change in number of protons, proton is a nucleon, change in number of protons or neutrons, isn't it? So especially proton, when there is a variation, then the new element will be formed. Okay. So for example, in case of alpha neutron, okay, when the nucleus, heavy nucleus, when it is made to react with alpha, when the heavy nucleus is bombarded with alpha, okay, so the new element will be formed with the liberation of neutron. But alpha is helium atom, okay, which carries a positive charge, and the nucleus is, any nucleus is positively charged part. So there is a repulsion, or the nucleus will repel the alpha particle. So alpha particle is being bit heavy particle, and in order to react with any nucleus of heavy element, the alpha must be imparted with extra energy. So the alpha, it is a positively charged and heavier particle, and only when it is energized, that means when it is imparted with extra energy, and that can be done in particle accelerator device. Okay, in that machine, in that device, we can accelerate, we can impart certain energy to the alpha particle, and such alpha particles, when they are allowed to bombard with a nucleus, and they will react, or the nucleus will be penetrated, or these alpha particle will penetrate the nucleus, and reaction will take place, and thereby the new element will be formed with the liberation of either neutron or proton. Okay, similarly, when the reaction, when the bombarding element, when the nucleus is made to react with protons, okay, they react, the proton is singly charged, singly positive charged, H1H it is, say, it can easily penetrate the nucleus, and it reacts with the nucleus and generates a new element with the liberation of alpha particle, or with the liberation of neutron. Okay, similarly, when the element or the nucleus is made to react with, when it is bombarded with, say, neutron, neutrons are neutral, they easily penetrate any nucleus, and thereby they react with the nucleus and changes the nucleons or the nucleus into a new element with the liberation of either alpha or proton. Okay, such reactions are said to be transmutation reactions, or say nuclear reactions, nuclear transmutation reactions. Okay, so we'll take certain examples under these types of reactions. See, the first type of reaction, alpha proton type reaction. Okay, for example, when the nitrogen is made to react with alpha particle. Alpha particle is nothing but helium atom, isn't it? So it bombards with the nitrogen and produces oxygen, and with the liberation of 1H1. Okay, so similarly one more examples we can give, and the aluminium 13, and it is made to react with helium particle, and it produces silicon, okay. So these are the two examples for this one. So we'll take the alpha neutron reaction. So neutron type of reactions. So here we can give the example beryllium, when it is bombarded with, say, alpha particle. So these are said to be alpha particle, and it changes on reacting with the nucleus. It changes into carbon with the liberation of neutron. Okay, so one more example you can give here. Another example, say boron. Okay, when it is made to react with alpha particle, alpha it is, this is the alpha particle, helium atom. So it changes into nitrogen, and with the liberation of, say, neutron, is it? So similarly we can take the transmutation by protons. So this is transmutation by, see, this is the examples for transmutation by alpha particle. Okay, this is transmutation. Now see the nuclear reactions or transmutations by nuclear reactions by, say, proton. So proton is nothing but 1H1. Okay, so we can give the examples here. Say proton, and the sodium made to hit or interact with proton, say the magnesium will be formed, Mg, new element will be formed, because there is a change in nucleus. Okay, with the elimination of, see, that means here the proton is used as a bombarding element and neutron is related. Therefore what type of reaction it is? Proton neutron reaction. Okay, this is the example. So one more example we can give of the same type, lithium. When it is made to react, hit with the, say, proton, you will get helium. Now here it is said to be helium, and another one is proton. So both are the helium atoms, but one is referred as alpha, not proton. Alpha particle is liberated and helium is liberated or formed. Okay, so this is the, say, alpha neutron type. So now, sorry, here it is alpha neutron type, this one, and here it is alpha, oh sorry, proton alpha type, is it? Proton alpha. See here, proton neutron. Proton is used as a bombarding element and neutron is liberated. Now here proton is used as a bombarding element, alpha is liberated. Okay, so now this is the first type, this is the second type, and this will be the third type, and this will be the fourth type, proton neutron, proton alpha particle. Okay, with this we'll move on to the next one, that is transmutation by neutron or nuclear reaction by neutron. Okay, so under this there are two types, so neutron alpha and neutron proton. Okay, we'll give the example for first one, See here the first one, first type. So under this, when the zinc, see 30, when it is made to react with neutron, neutron is 0, 1. So the this one will change into, see here it is, neutron is bombarding element and alpha will be liberated. That means alpha means helium atom, isn't it? So thereby there is a reduction in atomic number. The new element formed is nickel with 55 plus alpha particle. Alpha particle is nothing but helium atom, isn't it? So one more example of the type, say N proton type. Okay, so here N is the bombarding element and proton will be formed or generated along with the product or new element. So we can take the example, see nitrogen, when it is made to react with neutron, see the new element is formed, proton is liberated, therefore here it is carbon 6 plus proton is generated, and this is the proton. Okay, this one is the alpha particle. Alpha particle. Okay, so with this we'll continue in the next class. So okay, in the first here, when the alpha particle it is made to bombard with the lighter elements, say there is no such problems to accelerate or say energize the alpha particle. So only the alpha particle, when they react with the heavy nucleus, then it should be imparted certain amount of energy to penetrate, or it is made to penetrate, okay, the nucleus. And in other case there is no problem, and these are the 6 types of, say this is the first type, second type, third type, fourth, fifth type and sixth type. There are 6 types of nuclear reactions or transportation reactions are mentioned for your studies. Okay, thank you. We'll continue in the next class.